Just guess the frequency.
The only way to look after New Zealand sunfence interests is
just here in my workshop, and this nice parcel arrived from Alice Sperings from my YouTube friend Rustymotor. There's some really interesting goodies in here. An impulse lamp, NSP1. I need to look at the data, how that works. Today this video is about a neon pilot lamp from the 1940s, Crompton. And it's really cool. It's back in its home country. Made in New Zealand. So we're going to test it out on 50 Hz power supply. Of course Australia has the same 50 Hz. That meter floating around, so we're going to test it out shortly and see how it works. Yeah, I'm going to take the lamp out of its parcel and have a look at this. Crompton 200 to 250 volts. Made in England. Interesting, and I've got New Zealand on the box, probably for the market. Got this diffuser type part in here. Never been used. The bulb is still clear. No darkening of the glass. I'm going to plug it in. What I will do, I was told that it's got a built-in resistor. I'll put a temporary resistor in and then modify, take that out later on. I'll test this out. So just to be on the safe side, I know it's got an internal resistor. I'll put a sacrificial 22k resistor, 1/4 watt in series. So once it goes pop, then we won't destroy the lamp. Of course it's British, B22. Yeah, we're going to put it in and energize the device and see what happens. Oh, and it works. Fantastic. Turn the light off. Beautiful glow. Absolutely stunning. Turn the other lights off. Look at this. So nice and warm. Thank you, Ian. This is an amazing device. Absolutely beautiful. Made from Alice Sperings to Auckland. It's a really unique design compared with standard neon lamps. Normally the neon gas inside these bulbs strikes at about 70 volts, 60 to 70 volts, and there'll be a series resistor to limit the current. Otherwise it will be an instant flashover and a destruction of the lamp if there is no series resistor. Voltage is just a tad short of 240, about 238. Current to the lamp is 9.35 milliampere. It's an AC lamp. It's a bigger lamp, so it consumes a bit more, but 9 milliamps is not much, less than an LED. And now up to 11 milliampere. I just put another small neon lamp in series. No, sorry, in parallel. That's one of these tiny ones. Got two of these glowers. Now I'll turn the main lights off. I can enjoy this. Beautiful orange color. I just compare it on the other meter I have. That's pretty close together. The other one is 11.0 and this is 10.9 milliampere. I'm not going to quibble about that. Then I was also given a Philips NSP1 impulse tube, so I need to work out how it works. I'm going to look on the internet. Really cool lamp. And it's supposed to give impulses. I think it's got neon gas in there as well, so that will be investigated and put in another video. So that's a project to work on, and then I got a stack of MU10 high voltage diodes. You check the data on those things as well. They're really cool, long ones. They're quite big. So I need to work out the rating for that. It'll be good for an H3 project in the foreseeable future. A few more of those there, and then I need to have the other items stand by. Everybody who collects stuff, you end up with full workbenches. Like I got a pile of junk on my bench, but that's alright. I got some of these capacitor double voltage multiplier ones. I've got a whole stack of capacitors on here, really nicely made. And this one hasn't got the transformer, but I've got some other ones. They come out of, I think, dental units. We have a look here. Here's another one. Another two actually. Everybody who collects this stuff will get it out. So I'm going to work out how they work. I need to investigate that. They're beautifully made circuits. They've got a transformateur on it. I need to work out the wiring diagram on this and then see if I can get it to work. There's another one in this pack here. So there'll be another video how I'm going to get those things to work. Not sure how it's going to work, but we'll sort it out. This was mainly about the neon lamps, and I'll document this all the top equipment. It's also for everybody who likes this stuff. But in years to come, everything is digital, and hopefully this is going to stay on the web as long as sites like YouTube and the likes exist. And you never know. So thanks for watching for now. And maybe, I'm not sure if I mentioned that this clock is still running. It runs a bit slow. That's the clock. I had a shorty video. That call I wound quite a while ago. Designed for 50 volts, around 50 volts, 60 volts. Yeah, that's on the Variac. Yeah, it sits on a low. I need to put a series capacity tar in there. And then, yeah, I'll just give you an overview of my messy workshop. It's all these things, you need to find time. I've not always enough time in a week to do all these things. But that's alright, that's alright. This is a very messy workbench, but I'll survive on it. Give you a bit of an overview, a lot of crap floating around. Yep, thanks for watching. Rodalco 2007. And yeah, look forward to the summer so I can do some more outside experiments and working on a good capacitor bank to blow stuff up as well. That's another project I'm working on. Yep, cheers, see ya.